All right, everyone. Our next presentation is on the relevance of low molecular weight compounds on monitoring for direct potable reuse. This again is another one of the research focus areas identified by this NWRI expert panel as they looked at the feasibility of developing uniform water recycling criteria for the state of California over the last 3 or 4 years. Jeff is a client director at Black & Veatch. He's based here in Irvine. His expertise is in the development and application of advanced water process technologies, including the evaluation, pilot testing, design, and operation of those systems. He joined Black & Veatch in 1998 and held numerous positions in the Kansas City office before relocating here to Southern California. Dr. Neeman has a special interest in developing and applying big data and technology solutions for the water industry, and has contributed a number of notable water reuse projects, including the award-winning Bundamba, did I get it right? Bundamba? Close enough. Bundamba Advanced Water Treatment Plant near Brisbane, Australia, and the Southern Nevada Regional Water Reuse Study, the initial expansion of the Orange County Water District's GWRS in Fountain Valley. Dr. Neeman received both his BS and MS in Environmental Engineering from the Missouri University of Science and Technology and a Doctorate of Engineering from the University of Kansas. Please join me in welcoming Jeff Neeman.
Thanks, Kevin. Thank you. Good afternoon, everyone. All right, let's try that again. Good afternoon. All right. Come on, it's getting to the end of the day. It's a Friday. I know about everybody checked their Waze 405 traffic already. I'm impressed you're still here, honestly. So I appreciate that a few of you, I know a few that actually said they stayed to heckle me, and then they're heading for the door. So I appreciate that aspect. I'm going to try and keep this kind of lighthearted. If you know me, that's kind of my style in that aspect. So I appreciate the opportunity to be here. It's great to see all the students around. That's also great. So we have 5 openings around Southern California for new grads. And the trick is that a resume attached with a $20 bill gets you to the top of the stack. So just a little hint from inside, just to let you know. So I'm going to talk about low molecular weight compounds as it relates to monitoring. And it's going to kind of dovetail a little bit of what Andy just talked about. I think Andy spent some time talking about those compounds and removal. And I'm going to put a little bit of a bent on it from a monitoring standpoint of how do we know when these things are in the reuse water or in the finished water, more in a real-time, or maybe I'll even say near real-time aspect of this. So how do we know they're there in that? So I'm not going to try and pronounce LMWMC as an acronym. We love acronyms, right? So it doesn't quite roll off the tongue. Anybody see the coming to, or not, Robin Williams, Good Morning Vietnam, the VP, such a VIP, should we keep the PC on the QT? Because it leaks the VC, we'd all end up on KP, right? So I'm going to try not to use that, but my objective today was to really, as I talked to Kevin, is, so what is this? What's important? What are the treatment implications? Where are some of the gaps? And then what I want to do is maybe have us think about an alternative monitoring concept. And that's really what I want to kind of leave you with, is maybe from that thinking standpoint. So when we start talking about these compounds, we've heard them throughout the day. You may hear it as low boiling point chemicals, organic solvent extractable chemicals, CECs, pharmaceuticals, total toxic organics was one of the ones I wrote down today. There's a lot of different ones that come in this aspect. Really what it relates to is we're talking about compounds or fractions of natural organic matter maybe that have a smaller size. And I'm going to come back to the importance of this aspect of size and what it looks like. And what the size relates to is then that it can diffuse through the cell walls, and then we may have a potential health impact there, right? And it's no surprise that a lot of the drugs that we talk about and take are these same similar small molecules because they can transfer through. And so that's one of the aspects of these compounds that we're really focusing on and why we're looking at them. And so just around the water industry and what we're talking about, I think I checked off almost all of these on the list in terms of the previous presentations. We're talking about NDMA, chloroform, 1,4-dioxane, acetone, aldehydes, a lot of which are known, but we have a lot that are unknown in that aspect. And that's really one of the challenges, and Andy alluded to some of that in his presentation when he was talking about the monitoring, is, well, okay, hey, you can tell me what's here, but what about the things that you can't tell me are there? And that's a key aspect. While there are those compounds that are in the wastewater, there's actually disinfection byproducts. So some of the things in the treatment we're using could actually be these compounds of concern. And so that's something we have to factor in. I'm going to talk a little bit about. And of course, the challenge is they're typically at very low or even trace concentrations, so less than a milligram per liter of TOC, and we're really talking parts per billion or parts per trillion. So that's kind of the aspect of it. So why is it important? Well, they are present, and the removal and formation varies in that standpoint. And that's what I'm going to spend a little bit of time talking about. So when we start thinking about direct potable reuse, and I totally agree with the comments, potable reuse is really what we're talking about. But a lot of what I'm talking about in the context, especially the project, was part of the DPR initiative. And DPR could contain contaminants that represent a health risk, impact some kind of aesthetics from a standpoint of taste and odor, or have some undesirable consequences like affecting later on disinfectant residuals. So that's an aspect of that. So it's critical to monitor and detect these contaminants. But what's the challenge there? Few can really be done real time. Most of them require kind of an offline aspect to it. And some of them we even need to use surrogates or indicators to find that from that standpoint. The point being is it takes time, right? And the key aspect, if we start thinking about potable reuse, and especially the direct potable reuse, is the person that's there running the facility is, how do they know, is the water safe to deliver, and when do I need to act? There's some very basic questions that gets to the more aspect of real-time monitoring that I'm going to come back to in a little bit, and from a standpoint of chemicals of concern. So when we start talking about monitoring contaminants, a large part of those, the sources could be the industrial and commercial activities that feed into the wastewater system. And if you were here this morning and saw the source control presentation, you kind of alluded to that and saw the aspects of how much of a focus the Sand District and Water District put on what's coming into their system is important. So the concerns are these small concentrations that we can't really detect normally, and the concerns for the peaks is another aspect. And we may put these chemicals into a couple categories. One, things that are not easily removed by the treatment, because if they're not easily removed, they may pass through. And second, ones that could be really there in high concentrations. And again, let's not forget about the DBPs where we're forming our own things, as we've alluded to before. So I bring this up. I don't like to point the negative aspects of reuse, but it was important because when you do go to the expert panel report and they talk about these low molecular weight compounds, they brought out the experience within Orange County Water District. And you heard this before as it referred to the peak of acetone. And I wanted to highlight this aspect from a monitoring. This data of coming basically before and after the RO is from online TOC analyzers. So this is the real-time data aspects. This wasn't grab samples, it was real-time aspects of TOC. And you can see that when this event did happen, it responded from a standpoint of the monitoring. So that's an important aspect in terms of that specific event. But some of the questions is, does this happen more than we expect? And that same data, when they looked at this and looked at it over the course of several years, there were several times in which things happened and came through, and you look at it from that standpoint. So, okay, we know there are potential there. How do we get back to the aspects of monitoring? And that's the important part, and one of the things I want to talk about. So, in addition to peaks, there's other of those low molecular weight compounds that are present at these trace concentrations, right? And they may not be picked up by the TOC analyzers, either because they're so small or because they just aren't reactive with the TOC analyzers and the methods they're using, right? And it gets back to almost what Jim was talking about this morning of the strong source water control programs, And I like the fact that he brought up his environmental reporting and how they use that to check where the chemicals are and the people that are within their watershed. But what about some of the compounds that are maybe the secondary products that are being discharged of that? That could be a concern when we start thinking about this. And so if we're looking at these other compounds, especially that's where a lot of sampling, especially at the initial part of it, may be very important during startup. So we've kind of gone through the aspects of what they are. So what's the treatment implications that we really start to think about? And from many aspects, these compounds kind of fall into that category of not really high removal, not the 6-log removal like we're talking about sometimes with viruses in it. And so RO is moderately effective for some of these compounds. And the key gets back to RO rejecting 150 to 300 Daltons, and some of those compounds being in the same size range, right? So you may see RO removal of some of these compounds in the 40 to 90% range across that, highly dependent on the chemicals, their size, and the property aspects. So even though we, as Andy alluded to, we put RO on a high pedestal, when we start looking at some of these compounds, RO doesn't necessarily reject all of them. Other technologies vary by compound to compound, AOP being effective for NDMA, 1,4-dioxane, as you saw in some of the previous presentations. Ozone for organics, that standpoint. But what does ozone do in a lot of cases? It takes some of the large organics and chops them up into lower molecular weight compounds, forms aldehydes in that aspect. So DBP aspects that I was mentioning. So when we look at it from a treatment standpoint, how does the peak concentrations may be affected is something to think about, and multiple barriers when we can. That's an obvious aspect. And I like this discussion on the GAC at the end of Andy's talk, right? So would you be better with one of those barriers together or the two? And the flexibility of having the BAC followed by the GAC, in his opinion, I think speaks to that aspect. So for the students in the room, there will be a quiz on this at the end of my talk in terms of each compound as it relates to the difference. But the point being is just, again, this is some data developed by Shane Snyder and Ian Pepper, is that varies across these. You take any one of these compounds and no one technology necessarily does great, nor is there, any one of the removals that work. And so, yeah, you do see some slightly favoritism to the reverse osmosis. Ozone, not bad. GAC can be effective too, and even the AOP side of it. So just wanted to make that point from a treatment standpoint, that there is a little bit of everything when we start talking about these. But what if no RO? And I think Andy did a really effective job of talking about that. So some utilities are looking at non-RO aspects, no brine disposal or other local conditions that warrant that. So I think he made a good case. What I'd look at it more from the monitoring perspective is, okay, it may require more frequent monitoring from that standpoint. Maybe we want more sewers or sensors in the sewer shed to know these things are coming from that standpoint. And then how do we address the compounds that are not detected by the TOC analyzer? And I'm going to circle back on that here in a little bit when we talk about monitoring, because I think some of the things he was talking about bioassay-wise is one of the other ways to potentially do that. So yes, it can be done. It's just maybe from a treatment standpoint, or more specifically, monitoring for these low molecular weight compounds in a train with no RO. We just have to think about it a little bit different. So I've made reference a couple times to the disinfection byproduct side. So chlorine and chloramines have those potentials for chloroform. We think of sometimes chloroform just as the tip of the iceberg when we start thinking about byproducts, brominated, iodated, other compounds. NDMA, you've heard that referenced a couple times today in terms of the potential of forming more or being the worst enemy from that standpoint. Ozone, bromate formation, that was a good discussion before. I've done a lot of work in bromate, I have 2 patents, and I can tell you the number one thing to control bromate, feed less of it. That's really what it comes down to. And that's part of what, when you heard Andy's answer, the strategy of not maintaining the residual or getting the oxidation benefits but not driving the CT, that's usually where you get a lot of your bromate, is the maintaining the residuals. So that's a great aspect of that. But then the other parts, the aldehydes or NDMA that may come off the ozone process, is something you have to factor in, and they looked at it from a GAC standpoint. AOP is specifically there, I reference, meaning more UV peroxide aspects or UV chlorine. Don't seem to see as many potential, don't see the same things that we sometimes do with an ozone. And really, it's how does this factor into those other processes, such as the RO, the BAC, GAC. And I think through the talks today, you've kind of heard this aspect of, okay, which order do these go in, Ufo talked about kind of how you were trying to do the disinfection, what order makes sense. And that's something when you start thinking about these low molecular weight compounds that maybe you have to think in that aspect from the byproduct standpoint. So what are the gaps in monitoring? And this is alluded to a couple times today is, okay, we usually think of these physiochemical techniques, GAC, HPLC. One of the specific research recommendations was around really identifying those low molecular weight compounds or the unknown aspects of that. And that's really, I think, the gap when you start thinking about it, is the understanding of the remaining fraction of the natural organic matter, TOC, however you want to think of it, what's there and what does it mean from that standpoint. And it's those potential, and this is some of the work I'm referencing relative to 1401, the Water Environment and Research Project, that Shane, Schneider, and Ian Pepper are really looking at is biosensors or bioassays in terms of what that can be done. And Andy was looking at more of an after the fact, but they're looking at it from a standpoint of more real-time or near real-time aspects. Are there certain bioassays, biosensors that can be done that might put something a little more direct into the monitoring part of it? And whether they're specific compounds or non-specific, there's different parts of it. Some of the literature review they did, they identified something like 50 different biosensors that might be applicable, but then they just looked at the research that's been over the past 10 years and how it's gone up 3 or 4 times the amount of papers that are out there, people looking at this type of topic and looking for the biosensor side. So if we're not quite there from an analytical and we're getting there or we're finding other techniques, it gets us back to we need to think about other ways. So are there indicator compounds for this? So an individual compound that represents the characteristics of the family. Hopefully it's also conservative in its removal, that all the other compounds go higher. That's a great approach, may work, something like an NDMA representing the other aspects, but it's not a one-size-fits-all, and there's still lots of other compounds from that standpoint. Surrogates, physical and chemical properties that can be correlated to how the process is removed. So think total organic carbon or conductivity on the reverse osmosis that we could relate to that. Or in the case of ozone, the change in UV absorbance. So there's been a lot of work showing that especially with compounds of emerging concern, you can relate the change in UV absorbance to the removal of those compounds and even predict that aspect. So there's a great example of how we could monitor with UV absorbance and have a surrogate for really those low molecular weight compounds like that. So I have a show of hands, again, where I noticed a couple people nodding off. Is the photo on the left an indicator or a surrogate? Indicator? Surrogate? I don't know. I just thought it was an interesting picture, talking about real-time monitoring, right? So that brings us to the online TOC. And is it the only answer? Well, probably not. It's great. I mean, when we looked at that acetone peak. It's great. Showed that response in that aspect. But what about other compounds that aren't necessarily reactive in that method? What about the fact that when we were looking at, Andy's TOC values of 3, how many times do you ever see a TOC value shown past the 10th decimal, right? It's usually point something. And we're talking about concentrations of parts per trillion and parts per billion, right? So there's a lot of things that just aren't going to really show up even when they're at a high concentration or peak in that standpoint. So how can we think about other aspects of TOC plus UV224 plus other aspects? And so in 1401, that's one of the things Shane and Ian Pepper have been looking at is some of these other potentially commercially available sensors that we can start to pair together. The typical aspects of pH, conductivity, TOC, UV224, but then even looking at fluorescence. You saw some of Andy's graphs showing even fluorescence of that aspects and how that's an easy way to look at the organic aspects and show the differences in that. So I spent a lot of time all right, there's lots of these compounds. Yeah, they're there and there's peaks, right? Okay, we don't have great methods. The treatment's kind of in this aspect. So what I want to spend the last couple of minutes talking about is there another way to maybe think about monitoring, especially as it relates to these smaller or low molecular weight compounds? So this is where you're going to think a little different, a little bit of our audience participation. So over 1 billion credit card transactions in 2015, right? How many people have had fraud on their credit card? Come on, be honest. Is there anybody that has not? Oh, I'm surprised. But okay, so when that happened, right, somebody went through your report and was looking at a piece of paper or, report, Excel data. Oh, wow, something's going on here. No. Machine learning, aspects of analytics and data that are monitoring the 100 billion credit card transactions, and I got a text just not too long ago that something was squirrely with mine, instantaneously like that. There are 20 plus emotional recognition applications out there that can take video and pictures and tell if somebody's sad, happy, angry, mad in that aspect. Let alone think about what we're using from a security standpoint, border security, right? People coming into our country and how they're doing facial recognition aspects to that. The day a computer writes a novel, artificial intelligence was used to write a short story, and it passed the first round of a competition against humans. It's pretty impressive in my mind. Now, it didn't win, but still, You think about that aspect. So we live in this world, everybody's got more computing power than the Apollo 13 program in their pocket or on their desk, and they probably checked it 5 times since I've talked. But the point being, we live in this great world, right? But we work in an industry that has prevalent data silos. If I asked a lot of utility people right now, well, hey, can you give me your meter data, your water quality data, your SCADA data, and maintenance data? They'd have to go talk to 4 or 5 different people, and a couple weeks later, they'd get back to me in that standpoint, right? We live in a spreadsheet world too, where we take this data and we export it and we spend time and we analyze and we get an answer. Well, what's the problem? As soon as you've done that answer's out of date, right? So how do we do that more continuously? And then in my mind, I mean, our idea a lot of times of monitoring is a high or a high alarm or a low alarm, right? That's about as sophisticated as we start thinking about when we start talking about monitoring and alarms. So how do we go beyond that? So the big concept, anybody have one of these? Few people? Anybody? Really? Seriously? Nobody? Oh. There's some gray hair in here. I thought there would have been some people that would have had one of those. You know, that's what the phones are. So what's changed? Cost has gone down. Well, I don't know. The latest iPhone is how much? Over $1,000 or something? Maybe the cost isn't quite done. Size, availability, function's gone way up, right? We're tied to this aspect of what cell phones do. And so the big idea in my mind is data, or more specifically, doing analytics on that data to gain value is what's going to change from a monitoring standpoint in the water and wastewater and reuse industries. So what's changing? Cost of storage is going way down. Who actually pays for a USB thing anymore, right? You used to have to go buy those. Now you get those for free. Cost of sensors going way down. We're putting, 6 or 7 sensors on a chip and sticking it in a pipe now. Computing power is going way up and access is going way up. So I think that the potential for technology to transform how we make decisions is really the key aspect of this. Then I'm going to transition. So this is part of Water Environment and Research Foundation's 1401 project, where we're really looking at this and how it applies to potable reuse. And so I just want to walk through this concept in a simple form. So how do we take a wide view of the data? Yes, that we have water quality sensors, but we also have operational performance data that's coming from maybe a SCADA system. Yes, we have offline water quality data that's going to a database somewhere. We have event data, that, other things in logs, and we even have maintenance data. And then how do we take all that, connect it, and then put a layer of detectors or software detectors on top of it? And so, yeah, there's some sensors that are going to go straight to a certain detector, right? We may have some very specific, okay, this analyzer, this kind of critical control point aspect. But then, to me, the power may start to come when we start to go, hey, what if we combine the online and offline water quality data and have software look at that? What happens when we combine all these things? We end up with this layer of software detectors. And so the concept is that we can monitor all these different data and look for different things, look for different operating scenarios, and then eventually bring that to a decision support tool. And that decision support tool then really becomes the interface with the operator. The operator doesn't have to know about the artificial intelligence in the backside of it. They want to know, hey, something happened and what do I do? And so how do we do that? And so the objective of our project is really to develop that framework for the bottom and actually a prototype of a tool for the top part. And so maybe to give you an example, we think about the critical control point philosophy, right? And at microfiltration, the key aspect is that direct integrity test, right? Daily direct integrity test, and what's that come out to? It's a single value of which we worry about a trigger at some point, right? Well, maybe we could have the system not only look for that aspect, but it looks for the direct integrity test value across all 15 different racks. Maybe it's going to look for the change in the direct integrity test from day over day. Maybe it's going to look at the starting pressures and ending pressures. It's trying to look at it a more sophisticated way to tell you that something's changed before you ever hit that trigger point where you had a problem. So if we could program it to look for that situation, maybe I could find out before that happened as opposed to when it hit my trigger where it's at a regulatory limit aspect. So that's just the concept, if you will, from that standpoint. So how might it apply to low molecular weight compounds in DPR? Well, we would think of it more in that widespread. We could have sensors of water quality sensors in the sewer side of aspects, right? Have sensors in the water reclamation facility. We could have sensors in the actual DPR facility. our offline data, and even the operational data, really all trained to come together into that artificial intelligence in some kind of detector that makes sense, and bring it together into a simple dashboard that, hey, red light, green light, even you saw that in Andy's presentation, and that concept of real-time monitoring. How do we then take the smarts and put it into something in terms of red light, green light that's simple and actionable from that standpoint? So just a couple final thoughts. A lot of positive aspects of DPR and potable reuse. So some of this in terms of monitoring, talking about this, it could be negative, but there's a lot of positive aspects. But when we start doing this, we need to look at those low molecular weight compounds. We know they're there in small compounds, or small concentrations. We know there's the potential for the peak. And we know treatment and formation of these things have to be thought about. But then we start thinking about these monitoring, yeah, online TOC is a great thing, but how are we going to think about some of these other situations, and how are we going to think about all these data sources in that aspect? So that's all I had. I appreciate your time today. I appreciate you sticking around. The 405 did get about 5 minutes worse. I did just check that on my watch. So, but if we have time for a question or two, I'd be glad to. But if not, okay. Thank you.
For Jeff, any questions?
Quiet.
We need more cookies, maybe? Well, if we don't have any questions, Jeff, thank you very much.
Thank you.
Appreciate it.